Bismillahirrahmanirrahim. The next topic is about the factor theorem. In order to understand the factor theorem, first of all, we need to know the difference between a divisor and a factor. Okay, what is the difference between a divisor and a factor? For that, I am going to take an example. Suppose that you have two divisions. What happened? Now, suppose that we have two numbers. One is 8 and the other number is 9, and we want to divide it by 2. You know that when 8 is divided by 2, what do we get the remainder? The remainder is 0. Okay, in case of 9, the remainder will not be equal to 0. Okay, this will be, and 9 minus 8, this will be equal to 1. Now whenever the remainder is 0, okay, if the remainder is 0, okay, then the divisor is called factor of that number. Okay, so over here we have a 0 remainder, so 2 is called the factor of 8. If the remainder is not equal to 0, as it is in this example, then 2 will not be a factor of 9, because the remainder when 9 is divided by 2 is not 0, it is equal to 1. So both these are called divisors, but over here the divisor is called a factor because it is giving a 0 remainder. So whenever we are doing division, and if a divisor gives 0 as a remainder, then that divisor is always called the factor of the dividend, So now it is clear that if the remainder is 0, then the divisor will be called a factor, otherwise it will be just called a divisor. Okay, now the next thing is to understand the statement of the factor theorem. It is the same as the remainder theorem. We have derived it from that. Factor theorem is that the polynomial x minus a is a factor of the polynomial p of x if and only if p of a is equal to 0. So over here we are talking about the division of a polynomial p of x by a divisor x minus a. Then they are saying that this will be called a factor of this polynomial x minus a is a factor of p of x. We know that this divisor will be a factor of p of x if the remainder is equal to 0. Now in the remainder theorem we had studied that the remainder is actually equal to p of a. So we can say that x minus a is a factor of p of x if p of a is equal to 0, and this is the statement of the factor theorem, because we know that this will be a factor if we get a 0 remainder, and we know that getting a 0 remainder is the same as getting 0 when you are putting a in this, because this actually gives us the remainder by the remainder theorem. So if we combine the remainder theorem with this statement, okay, what we get is we get the factor theorem. So let me read it again. The polynomial x minus a is a factor of the polynomial p of x if and only if p of a is equal to 0. It means that if you want to prove that x minus a is a factor of this polynomial, what you are going to prove is you are going to put a in that polynomial p of x, and if it comes out to be equal to 0, then this will be a factor, otherwise it will be a normal divisor. Okay, and this is the statement of the factor theorem. So the key points are that if you have a polynomial, okay, and you have a divisor which is a linear divisor, x minus a, okay, and you have the remainder which is obtained by putting a in this polynomial, okay, if this is equal to 0, okay, then if p of a is equal to 0, then x minus a will be called a factor. This is what factor theorem tells us. Okay, will be called a factor of p of x. Okay, so you have a polynomial and a divisor. This divisor will be called a factor if p of a is equal to 0. A is the number which we are subtracting from x. Okay, and this a at which the value of the polynomial is equal to 0 is called the 0 of the polynomial. X minus a will be called the factor. Okay, x minus a will be factor and a will be called 0 of the polynomial. It means that 0 of the polynomial is any number at which the value of the polynomial is equal to 0. Okay, so if p of a is equal to 0, x minus a is called the factor and a will be called the 0 of the polynomial. These are the main points that we have to remember. Now let's start the exercise. In the exercise we have the question, question number 2, part 1. Over here we have, if x plus 2 is a factor of 3x square minus 4kx minus 4k square, then find the value of k. So it is given that x plus 2 is a factor of 3x square minus 4kx minus 4k square. We are given a polynomial and a divisor. Okay, and it is obvious from the statement that this divisor is a factor. It means that x plus 2 will give a 0 remainder. Okay, when this polynomial is divided by x plus 2, because they have called x plus 2 as the factor, and this is the fact that we are going to use to find the value of k. Okay, so over here we have a polynomial. Question number 2, part 1. We have a polynomial okay, and x plus 2 is a factor of this polynomial. It is given in the question. Okay, and you have to find the value of k. This is the main question. Now if x plus 2 is a factor of this polynomial, it means that the remainder after this polynomial is divided by x plus 2 should be equal to 0. Okay, so what we are going to do is we are going to find the remainder by using the remainder theorem, and after that what we are going to do is we are going to put that remainder equal to 0, because x plus 2 is a factor of this polynomial, so it should give a 0 remainder. Okay, so first let us find the remainder when x plus 2 remainder is equal to will be equal to p of, we have a positive 2 over here. It means the number which is subtracted from x is actually negative 2, so here a is equal to negative 2. Okay, a is negative 2 and the remainder will be p of negative 2. So first let me find the remainder. Okay, if you put negative 2 in it, we are going to get 2 2s are 4, 4 3s are 12, minus minus plus 8k minus 4k square. Now this is the remainder when the polynomial p of x is divided by x plus 2. Now we know that x plus 2 is a factor of this polynomial. It means that it should give a 0 remainder. Okay, as x plus 2 is a factor of p of x. As it is a factor of p of x, so it means that it should give us a 0 remainder when p of x is divided by x plus 2. This means that as x plus 2 is a factor, therefore remainder should be equal to 0. That is, p of negative 2 should be equal to 0. Okay, if the remainder is equal to 0, this implies that p of negative 2 is equal to 0, because p of negative 2 gives us the remainder when the given polynomial p of x is divided by x plus 2. So if p of negative 2 is equal to 0, it means that we know that p of negative 2 is equal to this, so it means that this expression should be equal to 0. Now this is a quadratic equation. I'm going to multiply it with the negative sign so that I can get it in an ascending order with positive sign. So multiplying negative 1 on both the sides, I'm going to have positive 4k square, negative 8k and negative 12. The next step is take 4 common from the whole expression so that the coefficient becomes more simpler. Okay, 4 after dividing both sides by 4, what we are going to get, 4 will be cancelled out and this 0 by 4 is 0. So what we are going to get is, we are going to get the equation k square minus 2k minus 3 equal to 0, and this, after solving this equation, we are going to get the value of k. So the only step remaining is k square minus 2k minus 3, a solution of this equation. Okay, so the question was that x plus 2 is a factor of this polynomial. It was given to us and we had to find k. Now we know that when this polynomial is divided by x plus 2, then the remainder is equal to, by remainder theorem, should be equal to p of negative 2. So we found p of negative 2. Now as x plus 2 is a factor of this polynomial, so this remainder must be equal to 0, and this is the remainder, this should be equal to 0. We know that p of negative 2 is equal to this. So we made this whole expression equal to 0 after taking 4 common from it. We divided it on both sides and we got an equation which has much less coefficient as compared to this equation. Okay, so if there is something which is common to all these terms, then do take them outside. Okay, do take it common, it will reduce your work. Okay, it will make your calculation more easy. So whenever you have a choice, do that. Now we have to solve k square minus 2k minus 3 to get the value of k, which is the required thing. Now k square minus 2k minus 3 is equal to 0. Now we are going to try it by using midterm breaking. Now two numbers whose product give us negative 3 and whose addition give us negative 2. What are they? They will be negative 3 and 1. Okay, negative 3 plus 1. This will give us negative 2 on addition, and the product will be negative 3. It means the pair which will break our midterm will be negative 3 and 1. So k square minus 3k plus k minus 3 equals to 0. Taking k common, this is equal to 0. Okay, so this is the factorization by midterm breaking. Now if the product of these two is equal to 0, it means either k minus 3 is equal to 0 or k plus 1 is equal to 0. If k minus 3 is equal to 0, it means either k should be equal to 3 or k should be equal to negative 1. So this completes the solution because we got the value of k. Okay, now let's move to the next question. Now in question number 3, the question is, without actual long division, determine whether x minus 2 and x minus 3 are factors of the polynomial p of x is equal to such and such. Okay, so we are given a polynomial and we have to find whether x minus 2 and x minus 3 are the factors of these polynomials or not. Okay, so we know that these two will be the factor of this polynomial if the remainder is equal to 0. So what we have to do is we just have to find the remainder when this polynomial is divided by x minus 2, and then again once more we are going to find the remainder when the same polynomial is divided by x minus 3. If the remainder comes out to be equal to 0, then you know that the divisor will be a factor. Okay, so just we have to find the remainders in both the cases. Okay, remainder in first case, remainder 1, when polynomial p of x, x cube minus 12x square, the remainder when this polynomial is divided by, the divisor is x minus 2, and we have to check whether this is a factor of this polynomial or not. So what we are going to check is we are going to find the remainder. If the remainder is equal to 0, then it means that this divisor will be a factor of this polynomial. So in order to find the remainder, we know that by remainder theorem we can easily do that by finding the value of this polynomial at the point 2, because 2 is the number which is subtracted from this x and it is a linear divisor. So applying the remainder theorem, the remainder will be p of 2. Now the remainder in this case will be 2 cube is 8 minus 12 into 4 will be 48. Okay, plus this will be 88 minus 48. Now what we are going to do is we are going to subtract these numbers by using calculator. 8 minus 48 plus 88 minus 48. This is equal to 0. As P of 2 is equal to 0, it means that remainder is equal to 0. Okay, as the remainder is equal to 0, so this implies that x minus 2 is a factor. Similarly, in the second case, to check whether x minus 3 is a factor of this polynomial or not, what we are going to do is, so to find the remainder when this polynomial is divided by x minus 3, what we are going to find is we are going to find P of 3, okay, which will be 3 whole cube minus 12, 3 square plus 44 into 3 minus what was that, minus 48. Okay, so we are going to put 3 in place of x to find the remainder when this polynomial is divided by x minus 3. This will be 27 minus 12 into 9 will be here it is, 12 into 9 gives us negative 108 plus 44 into 3 will be 132 minus 48. Okay, I'm going to subtract these. 27 minus 108 plus 132 minus 48, this is going to be equal to 3, and we know that 3 is not equal to 0, so it means that the remainder is not equal to 0. Therefore x minus 3 is not a factor. Okay, so x minus 2 is a factor, okay, and x minus 3 is not a factor. That is what they wanted us to check, that whether x minus 2 is a factor of this polynomial or not. We checked it, we found the remainder, it came out to be equal to 0, but in case of x minus 3 the remainder came out to be equal to 3, which is not equal to 0, so it means that x minus 3 will be called a divisor but not a factor. Okay, and this completes the solution. Now let's do the next question. Now question number 7. P of x is equal to x cube plus lx square plus mx plus 24. So we are given a polynomial, okay, has a factor of x plus 4. It means that x plus 4 is a factor of this polynomial, which means that it will give a 0 remainder when this polynomial is divided by x plus 4, and it leaves a remainder of 36 when divided by x minus 2. Okay, this is the second information, the second divisor. They are saying that x plus 4 is a factor of this polynomial. It means it will give a remainder 0 when this polynomial is divided by x plus 4. And the second thing is that they have told us that x minus 2 gives a remainder of 36 when this polynomial is divided by x minus 2. It means that x minus 2 is not a factor because it is giving a remainder 36. So over here we have two cases. Okay, find the value of L and M, and we have to find the value of L and M. For L and M we need two equations, because we have whenever we have two unknowns, then we need at least two equations to solve the to find their values. So we are given the polynomial. The first case is that P of x is equal to x cube plus x square x cube plus L x square plus mx plus 24. This is the first case. Okay, we are given the polynomial p of x, which is equal to this polynomial. Okay, and it is given that x plus 4 is a factor of this polynomial. Okay, x plus 4 is a factor of p of x. If this is a factor, then it implies that p of -4. Okay, if you find p of -4, because -4 is being subtracted from here, so a will be -4 over here. P of -4 is equal to 0. Okay, p of -4 will be equal to 0 because x plus 4 is a factor, and whenever a divisor is called a factor if it gives a 0 remainder, and we know that p of -4 gives us a remainder when this polynomial p of x is divided by x plus 4. It means that p of -4 should be equal to 0. Okay, so what am I going to do is I'm going to find p of -4, okay, which will be -4 whole cube plus L whole square plus m into -4 plus 24, and make it equal to 0, because this gives us the remainder by remainder theorem, and they have told us that x plus 4 is a factor of this polynomial, which means that x plus 4 will give a 0 remainder. Okay, so now -4 cube will be 4 -64 plus this will be 16L -4m plus 24 equals to 0. 16L minus 4m will be equal to -64 plus 24 will be -64 plus 24. This will be equal to -40, and when shifted to the right hand side this will become a positive 40. Okay, so this is the first equation in L and M. Now we have to find one more equation. Okay, this is the first equation. In order to find the second equation, what we are going to do is we are going to use the second condition which is given in the question. Now the next condition that is given to us is that the polynomial leaves a remainder of 36 when it is divided by x minus 2. It means that, let me write this equation somewhere because we will be needing it. 6L minus 4m is equal to 40. This is equation 1. Okay, and now we are going to the second case. The second condition that is given to us is that p of x gives remainder equal to 36 when divisor is x minus 2. Okay, so it means that the polynomial will have a remainder of 36 when this polynomial is divided by x minus 2. It means that p of 2, which will give us the remainder, this should be equal to 36. So what we are going to do is we are going to find p of 2, and then we are going to make it equal to 36. This p of 2 will be 2 cube plus L 2 square plus m 2 plus 24, and this should be equal to 36. 2 cube is 8. This will be 4L plus 2m plus 24 is equal to 36. I'm going to add 24 and 8. Okay, and then I'm going to shift it to the right hand side. This will give us 8 plus 24 is equal to 32, and when shifted to the right hand side this will give us 36 minus 32, and so we are going to get the second equation, which is 36 minus 32 is 4. Okay, this will be a second equation. Let me simplify it more. We can take 2 common from both the sides, so this will be 2L plus m equals to 4, and dividing both sides by 2 we are going to get 2L plus m equals to 2. Okay, This will be the second equation. Now let us take these two equations and solve them simultaneously to get the value of L and M. Okay, the first equation was that one, and let me simplify that also, because we can take a 4 common from both the sides. Okay, the second equation is this one. Let me write both the equations. Let me write the first equation for 16L minus 4M equals to 40. This was the first equation. I can take 4 common from it, which will give me 4L minus M equals to 40. Okay, taking this equation, I'm simplifying this first. Okay, and dividing 4 on both sides, what we are going to get is 4L minus M. 40 divided by 4 will be 10. So this will be the first equation. Okay, this is simplified one. The second equation is 2L plus M equals to 2. Now we are going to solve these two equations to get to the value of L and M. Okay, so these are the two equations that we need to solve. Let me write them over here. 4L minus M is equal to 10 and 2L plus M is equal to 2. Okay, now this was equation 1 and this is equation 2. Now in order to solve them, let me first add them so that M cancels out and we get the value of L. So if we add them, we are going to get 6L. This will be cancelled out and this will be equal to 12. L will be equal to 12 by 6, which is equal to 2. So the value of L will be 2. Okay, and now putting the value of L in any one of these equations, we can easily find the value of M. Let me take this equation. 4L minus M is equal to 10. Putting the value of L, this will be 2 minus M is equal to 10, and negative M will be 10 minus 8. So negative M will be equal to positive 2 and M is going to be equal to negative 2. Okay, and this will give me the value of M, and this is what we had to find. This completes the question and the exercise 2. So the value is of L and M will be, L will be equal to 2 and M will be equal to negative 2. Okay, and this completes the question. Now the last question of the exercise is question number 9. Okay, in question number 9, let me write the question first. Now the next question is, we are given that the expression ax cube minus 9x square plus bx plus 3a is exactly divisible by x square minus 5x plus 6. Exactly divisible means that it will give a remainder of 0 when this polynomial is divided by this. Okay, we have to find the value of a and b. So it is given that this polynomial is exactly divisible by x square minus 5x plus 6. Now if this polynomial is divisible by x square minus 5x plus 6, then from division we know that it will also be divisible by the factors of this expression. Okay, so first we are going to find the factors of this expression, which by midterm breaking will be, over here the master product is 6. So two numbers whose product give us 6 and whose sum give us negative 5 are negative 3 and negative 2. Okay, so by midterm breaking, this will be equal to x minus 2. Okay, so I have factorized this expression, and the factors of these this expression is x minus 3 and x minus 2. Now it is given that this polynomial is divisible by this polynomial. Okay, now if this polynomial is divisible by x square minus 5x plus 6, then this will also be divisible by both the factors of this. It means that this polynomial will be divisible by x minus 3 as well as x minus 2. So it means that p of x is divisible by this, it means it will give a remainder equal to 0 when we divide the given polynomial by x minus 3. It means that p of 3 will be equal to 0. Also, as it is divisible by x minus 2 also, so p of 2 will also be equal to 0. So from here we are going to get two equations which will help us to find the value of a and b. Okay, so if p of 3 is equal to 0, it means that a into 3 cube minus 9 3 square plus b into 3 plus 3a will be equal to 0. Okay, p of 3 means a 3 cube. Okay, 3 cube is 27, so 27a minus 3 square is 9 and 9 into 9 is 81 plus 3b plus 3a equals to 0. Okay, so 27 plus 3a will be 30a. Okay, plus 3b will be equal to negative, this is negative 81. After shifting it to the right hand side, we are going to get 81. Now taking 3 common from this side so that we can get a simpler expression, what we are going to get is this will be equal to 81. Shifting 3 to the right hand side, 10a plus b will be equal to 81 divided by 3 gives us 27. Okay, so this is the first equation that we are going to get. Similarly, repeating the same procedure, we will find p of 2 and then we are going to make it equal to 0. So the first equation that we got is 10a plus b is equal to 27, and the second equation will be p of 2 equal to 0. I am going to put 2 cube minus 9 2 square plus b into 2 plus 3a equals to 0. So this will be 8a, okay, minus 2 square is 4, 4 9s are 36 plus 2b plus 3a equals to 0. 8a plus 3a will be 11a plus 2b, and shifting 36 to the right hand side, the second equation will be 11a plus 2b equals to 36. Okay, now this is the second equation. Now in order to find the value of a and b, we are going to solve them simultaneously. Okay, we have two equations and two unknown, so I am going to take these two equations and I am going to solve it for the value of a and b, which will give us the required answer. So we have one equation over here. This is the first equation. Second equation, 11a plus 2b is equal to 36. So these are the two equations that we need to solve to get to the value of a and b. Let me erase all this. Okay. Now in order to solve this, let me use the method of elimination. First of all, I am going to multiply 2 over here. Okay, we will get 20a plus 2b is equal to 27 into 2 will be, I think, 54. Let me check it. 27 into 2 is equal to 54. Okay, and after equating the coefficient, what am I going to do is I am going to subtract these equations. Okay, negative, this will be negative and this will also be negative. Subtracting these two, 20 minus 11 will be 9a, and this will be cancelled out. 54 minus 36 gives us, I think, 18. Yes, 18. Okay, and a will be equal to 18 by 9, which is equal to 2. So a will have a value of 2. To get the value of b, just take one of these equations. Let me take the first one. Okay, put the value of a into it and find it. B will be 27 minus 20, and the value of b will be 7. So these are going to be the answer, and this completes the question as well as the exercise. Okay.